There we go. It's a great website, bushyoga.com. Okay, a couple more slides on this, and then we're going to keep moving here. All right, the reticular formation. I want you to know, this is my all-time favorite slide on the whole planet. It's in like every single lecture that I do anywhere. It doesn't even matter. It could be about the feet. I always stick this slide in because this is just such a great, awesome picture of the back of the brainstem. Look at these beautiful thalamuses, and we can see the back of the caudate nucleus here. Okay, we got our little pineal gland and our superior and inferior colliculi. And here are the cerebellar peduncles, okay? And here's the fourth ventricle and the brainstem. It's beautiful. Okay, so two parts of the reticular formation. Pontine, I know, I'm a little whacked. It's okay. I did a lot of drugs in college, all right? I told you. You did. I think all great neurologists did that. Okay. Pontine reticular formation. So, reticular formation, what do we need to know? There's an upper part and a lower part. The upper part is excitatory. The lower part is inhibitory. That's what we need to know. The upper part is excitatory to our extensors, our axial extensor muscles, the things that hold us upright in the gravitational plane. This is normally excited by the cerebellum and the vestibular nuclei. What have I been telling you, right? And it's normally held in check by the cortex. And we'll look at that in just a second. Okay? So the pontine reticular formation, the rostral part, the upper part. When you smoke, right, we facilitate our upper portion of our reticular formation. I'm telling you to smoke, it's because you're becoming hypoxic. All right? And because you're becoming hypoxic, those neurons start to fire more, okay, which gives you the false sense of alertness. Okay. The medullary reticular formation is not really false, it's real. We can measure it. The medullary reticular formation, okay, is caudal, it's inferior to that, and this is inhibitory to the extensors and excitatory to the flexors. What runs it? The corticospinal and rubrospinal pathways, the two voluntary pathways we have. So when I fire a neuron, particularly a flexor, okay, I am exciting the inhibitory aspect of the medullary reticular formation and inhibiting my extensors, yin and yang. When I fire my flexors, I inhibit my extensors. Too much yang, not enough yang. Okay, we have like extensor yang deficiency here. All right? So, excited corticospinal pathways. Whenever you fire it, it's going to do that. So, we want to try to work that rostral reticular formation. Since the rostral gets its input from the cerebellum and vestibular nuclei, we want to influence those. Less cerebellar and vestibular input means less extensor tone, less excitation of the pontine reticular formation. Now remember, the reticular formation does what else? It also runs autonomics, right? Unilaterally on that side of the body. So less extensor tone means more flexor tone. Double whammy. Corticospinal and rubrospinal drive increases, inhibits extensors, plus I have this thing called reciprocal inhibition, right? When I contract one muscle, the muscle opposite relaxes, right? Sherrington described this in 23, right? So basically, if I'm getting my flexors more excited, I'm inhibiting them through reticular formation, and I'm also inhibiting them at a cord level through reciprocal inhibition. So the flexors are just, the extensors are just doomed. So that's why we need to help them out as much as possible. Drive the extensors. That is the take-home message.